Hello everyone, welcome to the video lecture series of the subject Operation Research. This is our third lecture related to the topic project management. In this particular method we will study about critical path method. As we had discussed in our previous lecture, there are two methods, critical path method and PERT, it is program evaluation and review technique. So this method we are studying, that is critical path method. So for the given example we will find the critical path. We had already seen how to draw the network diagram. So this is the data that is given to you. For a small project there are 12 activities, means the whole project is divided into 12 activities. The details are given below. Draw the network diagram and find its earliest occurrence time and latest occurrence time, critical activities and project completion time. So these are the things that we need to find for the given data, and for that the project activities are divided into 12 activities from A to L. Its dependence means predecessor activities are given and its duration is given for the completion, and that is in days. So for activity A, B, C, D, E, F, G, H, I, J, K and L, its dependence is given. For A, B and C it is not dependent on anyone, so those three activities are independent of each other. Then activity D is dependent on the completion of B and C, E is dependent on A, F is dependent on C, G is dependent on E, H is dependent on E, I is dependent on completion of three activities, that is D, F and H. J is dependent on E, K is dependent on I and J, and L is dependent on G, and its time duration is given. It takes 9 days, 4, 7, 8, 7, 5, 10, 8, 6, 9, 10, 2. So for this given data, let us draw the network diagram. So as you can see from the data, this A, B and C are not dependent on any of the activities. So we will draw that all the three activities individually, means separately. So this is activity A, activity B and activity C. These three activities are not dependent on anyone, so I have drawn it individually, means it is independent. Now activity D. Activity D is dependent on the completion of B and C. So with the help of dummy activity we can draw this. By extending this C with the help of dummy activity, we can draw activity D. Means after the completion of activity B and C, then only you can start activity D. So this is what I have drawn. Next is activity E. So it is dependent on the completion of A. So you can see over here activity A is already completed, so we can draw now activity E, because it is dependent on the completion of activity A. Similarly activity F is dependent on C, means on completion of C. So one can draw like this. This is F. Now you can see that over here it is given activity F was dependent on completion of C, so C is completed over here, and then after we had drawn activity F. Now comes activity G. So it depends on the completion of E. So E is already completed over here, so one can extend that, one can erect the arrow from there, and that is activity G. Again H is dependent on the completion of activity E. So you can draw like this if, and for the same of activity I, you can see it is dependent on all the three activities. So I have drawn this H arrow in the downward direction because now you can see that D, F and H After the completion of D, F and H, then and then only activity I can be started. So it will help us to draw like this, and our purpose of drawing the network according to the data that is given, that is served. Now you can see activity I will only start after the completion of H, D and F. So from that we had extended activity I, and H is dependent on the completion of E, so I have taken H out from the after the completion of activity E. Now comes activity J. So one can say that I and J, activity K depends on the completion of I and J. So I can draw like this. I can extend J from activity E, and at the same time this purpose of activity K is also served, because it shows you that as per the data, after the completion of activity I and J you can start activity K. So this is activity K. Now last activity L. So it depends on the completion of G. So you can see over here activity G is already completed. So we can draw like this. This is activity L. This is our dummy activity. This is just we are adding for the satisfaction or for fulfilling our requirements. So this is how dummy activity is added, and this is how the network is drawn. So now numbering the network, numbering the nodes. One thing you should keep in mind that its tail of any activity will have the higher number as compared to the head. Tail will always have lower number. This is called tail of the activity, and this is called the head of the activity. So tail will always have lower number as compared to the head. So numbering randomly, only thing that you need to keep in mind is tail should have lower number, head should have higher number. Okay, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this is how the nodes are numbered. Only thing you need to keep in mind, you can randomly number the nodes, but one thing only you should keep in mind is, okay, each activity's tail should have lower number and head should have higher number. You can take an example of this activity G. See, this is the tail of the activity and this is head of the activity. So tail will always have lower number and head will have always higher number. So this is how the network is constructed for the given data. Now we will find out earliest, latest time, critical activities and project completion time. Okay, hello friends. Now step 2 for the example. We had already drawn the network diagram for the given data. Now we have to find earliest start time and finish time and latest start time and finish time. So how to find that we will see in this particular. So this is the network diagram that we had already drawn. I have again redrawn in the next page. So now we will find out this values that is shown in bracket, that is time duration of that particular activity. So the activity A's time duration is 9, activity B's time duration is 4, C it is 7, for D it is 8, for E it is 7, for F it is 5, for G it is 10, H it is 8, I it is 6, J it is 9, K it is 10 and L it is 2. So this all the time duration has been written nearby to the activity inside the bracket. So now we will find earliest time and latest time. So for that there are two methods, forward pass and backward pass. These two methods will be used to find. Forward pass method and backward pass method. So for first of all we will use forward pass method. So using forward pass method we will find out the earliest start time. So all the values I have drawn the nodes, I have done the partition inside. So any project will start initially with the starting time of 0. So I have put 0 over here. Now for activity A, time duration is 9, so 1 to 4. So 0 and time duration is 9. So adding that time duration to the activity, so that will give us 9. 0 plus 9, that is 9. In the partition we will first of all find out the left hand side value of all the nodes. We will find first of all the left side value in the partition. So 0 plus 9, that is 9. 1 2 3, there is only one path, so 0 plus 4, it is 4. But here there are two paths to reach at node number 3. So 1 to C, the time duration is 7. So add 0 plus 7, that is 7. Here it is dummy activity, so dummy activity's time duration is 0. So 7 plus 0, that will remain 7 as it is. But to reach 3 there are two ways. One, you can reach 1 to 3, and second is it is 2 to 3. So here the time duration is 7 plus 0, so that is 7, and 0 plus 4, so that is 4. So selecting the larger value from 4 and 7, that is 7. Now to reach 6 there are three ways, but before that to reach node number 5 there is only one way, so 9 plus 7, that is 16. Now to reach 6 there are three ways, this way, and this way. So 7 plus 8, that is 15, 7 plus 5, that is 12, and 16 plus 8, that is 24. So there are three ways to reach at node number 6. Whichever gives you the largest value, that value you will have to put at the left hand side of the partition. So that is 24. Now to reach node number 7 there are again two ways. 16 plus 9, that is 25, and 24 plus 6, that is 30. So maximum that is 30, so I will put 30 over here. To reach node number 8 there is only one path, so 16 plus 10, that is 26. To reach node number 9 there are two ways, one is this and one is this. So 26 plus 2, that is 28, and 30 plus 10, that is 40. So selecting the maximum value, so that is 40. Again putting the value that is over here, same value we will put over here. Now we will use backward pass method, means all the directions of arrow will change. Now we are moving in backward direction, so we will subtract the time duration now. So to reach node number 8, now arrow's direction will be reversed, and the time duration that is available for that activity, that will be subtracted. So 40 minus 2, it is 28. Sorry, 40 minus 2, that is 38. Now 40 minus 10, so that is 30. Now changing the direction of arrow, so to reach node number 5 there are two ways, there are three ways. This arrow will become reverse, this arrow will become reverse, and this arrow will also become reverse. So 38 minus 10, that is 28. 30 minus 9, it is 21, and 30 minus 6, that is 24. Now to reach this node number 5 there are three ways, this, and this. 30 minus 9, 21, 38 minus 10, 28, and 24 minus 8, 16. So from that the minimum value that we will select. So 38 minus 10, 28, 30 minus 9, 21, and 24 minus 8, that is 16. So minimum value we will select, that is 16. Now again to reach node number 4 there is only one path, so 16 minus 7, that is 9. To reach this path, there is again only 1, so 24 minus 8, so that will be 16, and 24 minus 5, so that is 19. There is again one more path, but the dummy activities time duration is 0, so 19 minus 0, that is 19, and 24 minus 8, that is 16, so minimum value we will select, that is 16. Now again to reach node number 1, there are various paths. 9 minus 9 0, 16 minus 4 12, 19 minus 7 12, so minimum value is 0. So this is how we have calculated using forward pass and backward pass method. Now we will find out the using this forward pass and backward pass, we have calculated each activity's start time and finish time. So for activity A, start time, earliest start time is this. For activity B, earliest start time is at the left hand side of the partition. So for activity B, earliest start time is again 0. For activity C, again it is 0. For activity D, this is activity D, and that is shown by 3 to 6. So the value that is shown on the left hand side of the partition, that will show us the earliest start time for the activity D, and that is 7. Now for activity E, so here in our network diagram, activity E is shown by 4 to 5. So the earliest start time for activity E is 9. For activity F, that is shown in the network diagram with the help of 2 to 6. So the value that is shown on the left hand side of the partition, that is known as earliest start time, and that is 7. Now for activity G, it is shown by 5 to 8 on the network diagram, and earliest start time, that is 16, that is shown on the left hand side of the partition. Next is for activity H. So for activity H, it is shown by 5 to 6, earliest start time is 16. For activity I, it is shown by 6 to 7, earliest start time is 24. For activity J, it is shown by 5 to 7, earliest start time is 16. For activity K, it is shown by 7 to 9, earliest start time is 30. And for activity L, it is shown by 8 to 9, earliest start time is 26. So this is how the earliest start time is calculated. It can be found out from the nodes in which we have done the partition, and the value that is shown on the left side of the partition, that shows us the earliest start time. So now to find out the earliest finish time, the formula is EI plus TIJ, where TIJ is the duration of the activity. TIJ is the duration of activity. This is TIJ. So for activity A, that is EI plus TIJ, so EI is 0 and plus TIJ is 9, so it is earliest finish time is 9. For activity B, it is 4 plus 0, so it is 4. For activity C, it is 7. For activity D, it is 15. EI plus TIJ, so it is 15. Activity E, that is EI, that is 9 plus TIJ, that is 16. Similarly for activity EIJ is 7 and TIJ is 5, so 7 plus 5 is 12. 16 plus 10, it is 26. 24, 30, 25, 30 plus 10, 40, and this is 28. So this is how we can find earliest start time and finish time of the activities that are given. EI can be found out from the partition that we had made inside the node. this is the partition that we made inside the node. So the value that is shown on the left side of the partition, that will give you EI, and that is your earliest start time. Now latest start time. So how latest start time is found out? So for latest start time, and latest finish time. So for this, first we need to find LJ, then we can find the latest start time. In this we have to first of all find latest finish time, that is LJ. So how we can find the latest finish time? So let us find the latest finish time. So for that, the value that is shown at the right side of the partition, that will give you the latest finish time. For the latest finish time, the value that is shown at the right side of the partition, that is latest finish time. So let us find for activity A. So for activity A, you can see for activity A, this is I, this is J, it is 9. For activity B, it is 16. For activity B, it is 16. For activity C, it is shown by 1 to 2, it is 19. Sorry, this is a mistake over here. It is not 19, it is 16 over here. It is 16 over here. So it is 16. Then for activity D, latest finish time is 24. For activity E, latest finish time is 16. For activity F, latest finish time is 24. For activity G, latest finish time is 38. For activity H, latest finish time for activity H, latest finish time is 24. Activity H, it is 24. For activity I, latest finish time is 30. For activity J, latest finish time is 30. For activity K, latest finish time is 40. For activity L, latest finish time is again 40. So simple. Now latest start time can be found out because we have already found out latest finish time, that is LJ. So how we had find out? See, this is the node, this is the partition, for example, this is activity. So this side will give you EI and this side will give you, this is latest start time. The value that is shown on the left side of the partition, that will give you earliest start time, and the value that is shown at the end of the activity, means at the end of the activity, here the activity is completed at node number 2. So the value that is shown at the right side of the partition, that is latest finish time. For all the activities it can be found in this way. Now LJ is already found, latest finish time, so we can find out latest start time. So that is LJ minus TIJ. So LJ is 9 and TIJ, that is time duration, that is 9, so that is 0. For activity B, it is 16 minus 4, so that is 12. For activity C, it is 16 minus 7, so that is 9. For activity D, it is 24 minus 8. 24 minus 8, so that is 16. For activity E, it is 16 minus 7, so that is 9. For activity F, it is 24 minus 5, so that is 19. For activity G, it is 38 minus 10, so that is 28. Activity H, it is 24 minus 8, so it is 16. For activity I, it is 30 minus 6, so 24. For activity J, 30 minus 9, so it is 21. For activity K, it is 40 minus 10, so 30. And for activity L, 40 minus 2, so that is 38. So this is how the latest start time can be found. Now our task is to find the critical path for the given example. So how we will find the critical path? Now you can see in the network diagram the nodes that is having same value inside the node. The nodes that is having same, both the values are same, that activities or that path, that activities is called critical activity. So you can see in this path both the nodes are having same value, so this is our critical path. I am showing it by double line. This is 2 lines, then our path goes like this. How critical path is found? Critical path can be found by the nodes that is having both the values same. The node having both the values same, that will be our critical path, and the activities belonging to that path will be our critical activities. So this is our critical path. Here both the nodes are having same value, here also it is having same value, then here it is having same value, here also it is having same value, here also it is having same value. So this is our critical path. There is one more path available. Here also the nodes are having same value, so this is also I am showing it with the help of double line. So now there are 2 paths that is available. One is A to E, E to J, J to K. This is path 1. These are the 2 paths that we are in critical path 1, and second path, that is A to E, E to H, H to I, and I to K. These are 2 paths that we have got. This is path 2. Now doing the time, finding out the project completion time. So doing the summation of the time duration of all the activities that are critical. A, that is 9, E, that is 7, J, that is 9, and K, it is 10. So it is total 18 plus 10, 28, and 6, 9 plus 7, 16, 16 plus 9, 25, it is 35. And for this path, A to E, that is 9, plus E to H. For activity A, it is 9. For activity E, it is 7. For activity H, time duration is 8. For I, it is 6, and for K, it is 10. So now doing the summation of this, 9 plus 6, 16, 16 plus 6, 22, 22 and 8, 30, and 4, 40. So this project duration is 40 days. So project completion time, or that is 40 days. This is our answer. Project completion time. Here we are having 2 critical paths. Now in such cases, when there are 2 critical paths, available, at that time the path with the largest project completion time, that is our critical path. So this is all about critical path method. I hope you would have understood how to calculate the various starting time, earliest starting time and latest starting time and finish time. Thank you.